Hello, my outstanding friends. Once again, it's Roger the Rejector. And what am I rejecting today? Well, I'm rejecting the new Nobel Prize winning science. And I'm going to show I can reject it quite easily because I have the particles that show that the standard model is wrong. And they continuously try to stay within the standard model. It does not work. Okay, my friends, let's just start it right here. Einstein has been disproven. And these three guys got the Nobel Prize. Now, here's what they got it for. Listen to this.
They received the prize for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science.
All right, Bell's inequality. What is that? Let's find out. All right, here's another article about it. This just came out today. Scientists win physics Nobel Prize for proving Einstein wrong. And it's the same thing. This is Bell's theory here. And all it relates to is the locality of the particles. It's a little confusing. Let me explain to you. Okay, my friends, one of the rare instances when I agree with Einstein, but certainly not about this. The speed of light does not change even when the source of light moves. The speed of light is completely variable, so Einstein was completely wrong about that. Now, he is right, though, that quantum is insane when they talk about entangled particles. If you change something here a light year away, the same thing happens because you changed it over here instantaneously. That's insanity. And I mean literal insanity. And he was right. He said it was insanity. He hated the whole idea of that. He was appalled at that anybody could even think that. And he's right about that. About the speed of light, nope. All right, these are the smallest particles that exist. And they are from light. They are pieces of light. We accelerated light. That's not just light standing still. That's light accelerating. Not allowed under Einstein. And we've slowed it down too. Very simple to do. And we have split it, which is fusion and fission and fusion. Exactly what CERN wants to do. Muons and electron neutrinos attached together are these white and black balls. All right, just as they show up here. These are the fixed particles and these are the point particles. And this is understood. It's just that they don't realize where they came from. They come out of light. Light is made of those particles. When they're smashing protons together, they just get in debris, so they have no idea. They're seeing the same particles. But we can actually squirt them right onto a substrate right there and collect that energy. So I am against Einstein in most cases. However, quantum entanglement it's insanity to think that you can entangle something over here and have it happen a bazillion miles away. The exact same thing reflects it, or whatever they think. I have no idea how they could even come up possibly with that. But it's just a total waste of time. All quantum is semi-close. I'm probably going to show you an atomic bomb blast. That's as far away from quantum entanglement as you're going to get. You cannot compute with bomb blasts. Plus, at a certain point, they stop and fuse back together and become light again. And they stop being so destructive. You know, there is a certain distance. It's not light years. Okay, this is the New York Times, all the news that's fit to print. Well, this is the Nobel Prize in Physics awarded to three scientists working on quantum weirdness. They say that if you make a change over here in Connecticut, United States, over somewhere on the other side of the universe, instantaneously the exact same thing is going to flip out there because they are entangled. It's totally, literally insane. Now, Einstein said the same thing. He rejected it vehemently. He detested that idea. He said, you people are crazy. And he was right. Now, I didn't agree with anything else that Einstein said. You know, light can speed up. Light's a particle. It's a wave because it has a field that surrounds the particle. And as it moves forward, the wave pushes everything out of the way. So it's field-particle duality, yes. it speeds up, it slows down, and there's all kinds of different things that happen that Einstein didn't understand, and nobody understands, because it is a particle, and it is the tiniest particle that exists, is these two little particles right here. And they found them, which is the muon, the electron, neutrino. The two of them together make what we always consider was an electron. Nobody's ever known about the dark matter. Two electrons together is just like this. It's like two bar magnets. When they're together, it's a photon. When they're apart, that want to burn you. That wants to burn into you. This is heat. It's light. Not light. It's heat. It's lightning. It's static. It's electricity. When it's together, it's light. This will bounce off of you. This will burn into you. All right, so I have all the... Let me show you what we got. Okay, I've shown this so many times, I'm just going to bump right over it. Don Lincoln at Fermilab in 2013 said these are the two particles that they have found, the smallest ones. This black one never changes size, it's fixed. And this one, and I'm just going to cut right to the chase, and that's exactly what we have, exactly identical. Now, here's what he says, his final conclusion. He said, in summary, extended particles, which is the black one, have a fixed size. They may have a fuzzy edge around them. Point-like particles, though, as the glowy one, are mathematical abstractions with zero size. But even zero-size particles have an extended effect due to the field effect surrounding them. Now, and these are those two particles. Then he goes on to talk about the quantum foam. Well, here's the standard model. You could look that up if you want. Which is, that's what I'm saying is not correct. But he is correct about those two particles, and he's correct about the quantum foam. So let's just cut to the chase here. This empty space isn't empty. It's not empty. It's filled with the particles of light. That's basically, and this is exact same time, 2013. And so that's what we are. And the standard model is what I'm saying is not correct. The only thing that does exist is the W and the Z bosons, the white and the black particles. That's the only thing that exists. Okay? That's the burner, and it glows, and I show you all this, and I'll show you to you right now. And the other one is the muon, and never changes size. That's the fixed particle Don Lincoln talks about, and that's the point particle that can get big and small and burn and supposedly has no mass. And I basically agree with that, because in an atomic blast, the first thing to hit is the white ones, and they just burn. They don't move anything. Then comes the black ones, and poof, the whole house goes. But none of these exist. They are just bigger pieces of these little particles. The only ones that exist are these, and they're polar. There's a dipole, which means it has both the black and the glowy part. Now, two of these together makes a photon. So that would be normally what you would consider an electron. But that's the dark matter right there, attached to the glowy matter. And these electrons will burn into you, or they'll collect on you as static, or they'll go through a wire to make a motor run, or whatever. They are movable, little tiny bar magnets. These are complete. They have one back to back. Okay, basically like this. The two fixed particles and the 2 point particles are back to back. And they have a field surrounding mostly the white particles. All right? Now, these will bounce off of you because these will try to glue into you and burn you, electrocute you, and so forth. Now, once you get bigger than this, any bigger than this, you're into molecules and atoms. Now, the first stable chunk of this, because everything there is made of this. Everything there is made of these. And the black can separate from the white. Showing it, I'm going to show you again to you very shortly. So that's the only thing that do exist. So every single thing there is made of that. So the protons are nothing more than a big ball of that. They're not one of these like this. A proton is not like that. A proton is this, and every one of these is one of those. All right? And the first stable number is 1835. And at 1835 you have a proton. And what a proton does is, because it's an uneven number, the black particle that's in the center, the black core, is so attractive that it's sucking like crazy to grab another white particle and bring it in. But because there's already one extra white one on the core out, it says, no, 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 you can't come in. He says, no, I want to come in. He says, no, we got too many already. And they stay out here at a distance called a quantum distance. I'm going to show you with something simple called a tractor beam magnets. It explains it. It's elegant, really, to be honest. All right, nobody could explain it better than this. This is Latham's crazy machines. Incredible tractor beam magnets. Well, what is so incredible about them? Watch what happens. He's going to make the dark core, and then he's going to surround it with the glowy particles, and then you'll see quantum mechanics right in front of your face. All right. Here's what he's going to do. You see that? This is the glowy particles. Then he's going to put the dark core inside here. Just exactly what I showed before. So, and you'll see him do it. All right, so he's going to put it down. Now, the dark core is going to come up, bang. Okay, they're attracted. He's going to put that inside those white ones. So now, instead of the black coming out now, so what is it? What do we have here now? We have a dark matter core attracting the hell out of these, and these are going to push anybody else that wants to get into that dark matter. And it's exactly what happens, because it will continue to try to attract more. Watch this one. Bang. Done. That's quantum mechanics right there. That's exactly what you see in atoms. They have orbiting electrons, that's nothing more than an orbiting electron, and they sit at an exact distance away from the core, and they can be shaken and jiggled and so forth, but if they take off, it's called light or electricity or static or lightning. Boom, gone. Once it leaves that core, it's on its own, and it's heat. All right, as I said, this is critically important. You understand the standard model is not right. Okay, the standard model would have this as one gigantic positive, not a dipole. Now, this is a dipole. That means it has a positive and a negative. This is the electron that hangs around trying to get in. It wants to get to that black particle. The red one wants to get to the black one. And it says, no, we got enough red ones here already. Stay away. It says, well, no, I want to come in. It says, no, no, you stay away. And you saw he shakes it and everything. And then once it takes off, in this configuration, the black and the red together, it's heat, it's static, it's lightning, it's electricity. That's what these two together are. They are not the atomic bomb part where these separate. And an atomic bomb, they separate. The blacks come after the red burning one. Remember, the black one is just a solid piece. It doesn't heat up. It just pushes. It's a big banger. This one's just a burner. And I can prove this right now in an atomic bomb blast. Now don't forget, the standard model says one big solid ball of positive and one tiny little negative, and that's it. And it's crazy, because it would be the same charge. Hydrogen is one big gigantic particle, 1835 times bigger than the electron. So what this means is one electron it works out to be 0.0005854, I believe it is, atomic mass units. All right, 0.0005845, something like that. But 1835 of that particle, which is what we would consider an electron, all balled together in a ball makes the proton. I think I've shown you that. Now let's watch the atomic bomb blast, and it's virtual proof. All right, now don't forget, let's talk about what an atomic bomb is. An atomic bomb is nothing more than an accumulation of so much mass into one ball that it just wants to fall apart already. It just and then they coat it with explosives and force it in harder, and that's when it goes. And what will go is the red will go first because it's on the outside. It's always on the outside. Always, 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 always. The red is on the outside. It does not want to be next to each other. It pushes the black to the inside. So when that explosion goes off, the first things it leaves is the red. Well, what does the red do? They burn. They don't push anything. They have no mass to speak of. And that's not even my words. That's from Fermi Lab, and they're right, because you can see it just burns. And then comes the black one, which is the bowling ball, which is a fixed particle. Here it's going to come. All right, here's what's going to happen now with an atomic bomb blast. The atomic bomb, as I told you, is the black is in the center, the white coats it, just enormous quantities of mass in a tight space. You smash them in together and they bounce back out. Well, the white goes first. So what you're going to see is a whole bunch of this like red burny stuff. It's going to show up as white. And it's just going to burn the house, but it's not going to move it. Nothing's going to happen at all. And then you're going to see this just boom, boom, just go flying everywhere. All right. So that's what's going to happen. The first thing is the burner, and you can't miss it. It's it's impossible to miss. Okay. So here we are, and it's a time lapse, but I'm even going to make it go slower than that. So I'm going to make it go way down to half of the normal speed of the slow, and I'm going to turn the sound off, and here it goes. So here they are, and they're going to just see what happens when you set off atomic bomb. There it is right there. I'm going to stop it. Watch. Look at this. It burnt everything that was on the surface, just combusted it. You didn't see anything go moving, not a single thing. It just burnt this up. So that was the red ones. All right, and now comes the boom. Those are just bombers. Now watch what happens. You see it all turn around and come back? Why did it turn around and come back? The reason is because there's still a ton of the black particles back where the thing originated, and the white ones want to come back, so everything has to come back. Okay, I'm pretty sure I showed you that we found these exact same particles, and the fixed one never changes, and the point one is the glowy one and the burny one, and that's the one that hit and burnt up the house, and this one knocked the house down. And that's exactly what they are. One of them has no mass, and the other one is just nothing but mass. In summary, the extended particles, which are the black ones, have a fixed size, never change, although they may have a fuzzy edge. The point-like particles are mathematical abstractions with zero size. The red ones, they have really nothing to them, but even those zero-size particles have extended effect due to the field that surrounds them, and they just burn. So I agree with that 100%. Those are the particles, and he's saying they're very confusing because that's what they do, these two particles. These are the smallest particles I can find. And this was from Fermi Lab, where they're smashing particles together millions and billions at a time. See, we use light, so we are actually literally making a photon collider. The Large Hadron Collider, they wanted to do this, and they couldn't figure out how to do it. Now, this is a Feynman diagram of creating the W and the Z bosons, which are those black and white particles. Now, here's the problem. Here's the problem. The Large Hadron Collider, known for smashing together protons. In my world, a proton is a big, gigantic ball of electrons, which are these particles right here. And a photon is two of the electrons back to back. But an electron is both the muon and the electron neutrino. All right? Two of these electrons back to back make the photon. Balls of these make molecules and atoms. All right? And before you can get anywhere, the smallest one is hydrogen. All right, is the smallest one. It weighs 1 atomic mass unit, approximately, which means about 1,835 electrons. And then they go up from there, and then they get huge, gigantic balls of of stuff. They're not just, 25 and 35 and 6 and 12 and 14 and all these different numbers. There's 30,000, 45,000, 80,000. All right, that's why they can do such elegant things. Now, when they smash them together, they're smashing bunches containing some 100 billion particles. When the bunches cross each other, they're smashing them head on. Some of them collide, only about 25 or so. And that's where they're concentrating so much. They're spending trillions of dollars to do this, literally. So only 25 or so collide. But still, that's hundreds of thousands. The rest of the protons continue flying around through the LHC. Now, I went to the University of Geneva, and this was 5, 6 years ago, something like that. And I showed them us focusing in our light, and they were intrigued. They I took the physics, particle physics there, and so I have the photon-photon interactions. And this is exactly what they wanted to do. See this on here? The physics of photon collision has been a topic of some interest for many decades. Indeed, a special meeting in 1978 to discuss how to do it and to collide electrons with positrons. These collisions very clean as we're colliding photons, which are elementary particles, that's what we do, and not composite ones like protons. It was first proposed to do this type of physics at the LHC with CERN many years ago, but the project didn't materialize then. Well, we materialized it. So, and I think we can use it to get actually free energy. If the dynamics of what they say are true, it means that if we can separate and get muons separated from the electron neutrinos, the muon neutrinos separated, somewhere in their is fission, and then when they come back together, it's fusion. And somewhere between there is an energetic value that is just staggering. And we could see it. It's not something you can't see. You can visually see it. All right, this is simple as it gets. This is the pulsed red laser. So we're working with photons of light. That's exactly what they are, and I will show you them. They are here. They have to push their field, which is their surrounding magnetic field, that surrounds the particles. As they go through the air, the field is way out here. So they have a field and they have a particle duality, wave-particle duality. And there's the wave, the particle is back here. It's forcing every other particle to glow because they're being concussed. You concuss something, it glows. In this particular way of this smartphone, the way it's set up. It's picking up any kind of energetic reaction as a glow, and anything that glows is sending out energy. Now, this is as the light is literally accelerating. That is acceleration. All right? And the reason it's accelerating is fully understood is because of a venturi. And a venturi is nothing more than all it is this, something approximately like this. Now, I'm not sure what that dimension is, but when this light comes down, it has to force into there. When it does, it just bangs into each other. Now, it may have to, Rod Warren designed this. So he's the guy that you'd have to talk to, and he spent a ton of time, and I can never thank him enough for being able to do this because I could never prove my theory. Now I guess it's absolutely proven. This is a single slit venturi. Now, why is this is really much closer than this? These little black balls that were attached to white balls have separated away. And here's what they looked like when they were coming here. Right? They weren't just little white particles. They were these particles here attached together. You see the white and the black? You see the white and the black? That's what they were. Now, what happened to them? Well, they split. And they split when they hit this venturi right here. Right there, they divided. That's fission, called fission. In the nuclear realm, splitting something is called fission. When those things attract back together by their natural nature of physical particle attraction, it's called fusion. You don't have to do anything to make them fuse back together. They want to be back together so badly that the energy value here is astronomical. Just look. Look at the concussive whiteness. When we started out like this, this is nothing. Virtually nothing. This is as it starts to accelerate. And this is as it really starts to see. The first part was up way back here. Now we're really rocking. And then it exploded at the Venturi. You can't see the Venturi. I wiped it off. Now, coming out of here, if we were standing here looking in, we're standing here looking in. There is the Venturi coming out. These sprits are strictly the white part. It's just the white. Until they hit back in again, and they make these fields. These are called the Higgs fields. They have it backwards. They think the Higgs fields creates particles. Higgs fields are created by fusion. That's what creates Higgs fields. All right, so let's put it together a little bit. These are the particles from Fermilab, the dark fixed particle and the point particle, the no mass and mucho masso. All right, and here they are right there. And this is a photon. Now, if this was just half, either that half or that half, it doesn't matter. A black and a white one together is what we would always call an electron. These, they know they separate, but they also know they're together. They call them neutrinos. All right, that means this is the muon neutrino and this is the electron neutrino. When they come apart, they call them the sterile muon and the electron shower. All right, and they're right here. I'll show them to you again. Now, we know this is the particle that is the same particles that they have found at Fermilab, because we started with light. So we did what CERN wanted to do, just as I showed you. But we can do this, and not only can we split them like an explosion, which is all they're doing, make an explosion. We can spray them. We can spray them right onto a substrate. Why can't we do that? Well, I know we can do it. So all we have to do is take some kind of a harvesting device, and I don't know what you do, but let's just say you took a plate here that was these new perovskite metals. They're not new, but they're fashioned them in such a way that they absorb energy just unbelievably. As does light-emitting diodes. You know, I could show you some. Well, I'm going to show it to you, but I'll show it to you in a second. All of what we need to do is set this up so that we get it hitting here, splashing all over here. And we collect all that before it comes over here. We don't need to just throw it back together. Let's go through our device before it comes back. It so desperately wants to be back to the black, it will follow through a wire of copper, I believe, or some conductive material. I don't think you're going to be able to work this with light. I think you're going to have to push electrons, literal electrons, through copper. And light is nothing more than electrons. Light is electrons. Light is two electrons back to back, just like that. Each one of these is an electron, a fixed particle and a glowy particle. We've got to take a whole new idea of what electricity is, electrons, the periodic chart, totally got to be changed, everything. But everything now makes sense, and it allows for the elegance of chemistry and life and enzymes, bacteria, the very, very exotic nature of life and chemistry and all of that deep, deep, deep stuff is fully understandable now, because you could never do it with just a handful of chemicals. It's just a handful here. Really, that's it. It's not possible. And even if you look at it, every one of these has a ton of oxidation states, I'm sorry, a lot of them have oxidation states, but every one of them has isotopes. And an isotope means that instead of having the big ball of electrons in an exact quantity, you have a half a dozen missing or 20 extra or 15, and they have a half-life, and they sort of either take some on or give some up to get that nice stable core. We got some thinking to do on this, but this covers everything. The electron dipole flood theory is the new model, and it works, baby. It works. If you can come up with any single mystery, I can solve it using electron flood theory. 100% dipoles, and 100% of everything is made of that normally particle, which is these two pieces together, which are the neutrinos, muon electron neutrinos. When they break apart, they become stereo muons and electron showers, as you see here. Here's the neutrinos, boom, boom, coming in black and white ball. The muon still continues on as a fixed particle, electron showers right there. We did it, fission, fusion. I think we got raw energy. If this is the case, this is the solution to all of our problems right here. All right, we went through all this stuff. This is the electron showers coming out, and right in here there's nothing. You don't see anything, just these little spritzes. And then, like these here, this little white spritz. And then, bang, they hit other particles, and they come back together as the black and the white. See this? This is the leading tip of the wave coming at us. It's strange as hell. But that's what it is. This is that. All right, a guy named Fabien Boulay did some of this work and took Rod Warren's pictures, because Rod Warren did these. And he's the one that engineered the Venturi. And he just did it. It wasn't. He didn't go set out to do this to try to separate light. When I saw what he is doing, I realized what he had, and then he worked with me, and we refined the thing down to a point where we could see all of these particles. And I would ask him to try this, try that, try, and he would do all these kind of things, send me the results, and by the time we were done, as far as I'm concerned, this is 100% understand light now. I understand the difference between red and green and blue. And they're all the same particle. It's just more power, which means more spin, which means more impact value. All right, this shows you no question it's an impact value. You see the red, very, very weak. This is like there's a pin here, and then there's a pin on the other side of this Venturi. So it's just like this. And the green is above, coming through, and the red is below. And you see they're interacting, and the red's just getting pushed out of the way. The green comes back and continues to react way down here. Green is a powerhouse, but it's identical to the red. There's no difference whatsoever. All right, you see, there's the particles right there. It's the exact same particle. And there's the green coming through, but much, much more powerful. Much more powerful. You see here, it's showing the particles. You see a little tiny bit of red here and there, but the red is just, there's nothing to it. The green still has some energy. Way out here, it's still got its photonishness. There's a lot to understand here. The blue is another one. Blue is a real powerhouse. And then Dylan did this. This is Rod's nephew. He's just unbelievable. Look at this. He got a new phone, and he was out checking something with some app. And I think this is Venus, and I think it has a double field. You see this secondary field here? This is the real strong one. And then we have another one that goes right behind it. And Venus spins backwards, but it goes forward. And I think that might be the only way it could have two fields, and the only way it could have this kind of an effect too. And I have some other evidence that shows this could be Venus, but hard to say. A lot of work needs to be done. But you see these magnetic fields? These are push to shove. You see? Push, 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 push. That's it. It's pushed, shoved, and a little tiny less each time, little tiny, and then it gets out to the far outside and it just stops. It's done. But they always come back around. That's the nature of a dipole. You know, when it's spinning through space. See, here's green splitting the dark from the light. This is 100% light. There's no darkness spots here at all. There's just all tons of the dark went this way, but none this way. So we know we can divide these particles. We know they're the same particles. We know this one's much stronger than the other, and blue is even stronger than the green. And if we can harvest this division of the particles, they claim it's an enormous increase in energy, and you can see it. You can see the devastating increase. I mean, it's just unbelievable, the amount of glow, and the glow is energy. All right, light particles are entangled, no question whatsoever. The black and the whites are entangled with another pair of black and whites, but when they separate, they don't want to come back to the same ones. Here's what they look like. When they separate and the black goes on its way and the whites turn into a shower, they find new partners. And I believe I can show that without any question, unless somebody really wants to question it. Well, I'll talk about it. Here, hold on one second. Here's the red ones. All right, here they are right there. They're coming in that box, and then they separate. And the green one's the same way, and the blue the same thing. And when they separate, hold on, they turn into this. They turn into the black, stays black balls, and the white turns into showers. Now, these black balls don't jump over and attach back to the same one they were attached to, and they don't go to the other end of the universe to find the same white ones. I mean, I don't have any idea how they can make these statements they're saying. I'd like to talk to somebody about it and have them say why this isn't true. I'm showing the particles of light separating here from those black and whites. I showed you those are green, the same as this. And they turn into the showers, exactly what they say. CERN sees the same stuff. Only they're hitting the gigantic particles head on. We started with light. We're ending back with light again. And we really have a ton of energy here. I believe this is just raw energy. And if we can harvest it here and send it through our devices and then attach it back to a black particle somewhere, I think it can do a ton of work. All right, I'm going to make this so simple you won't believe it. Electrons and photons must carry some property or attribute not included in quantum theory. Correct. They're dipoles. The dark particles nobody knew about before. They see it when they break up protons. But we see it when we break up photons, as you will see. Okay, now this is the New York Times. This is all the news that's fit to print. So I believe I should have a say in showing my evidence that sort of runs contrary to what they're saying. That's what science is all about, is being presented with something, saying, whoa, let's take a look at that, and I can explain it. That's what I want, is an explanation of what I show.